Number 11, we want to draw the major products of each of the following reactions. Will be stereospecific when necessary. So the first one here, we've got sulfuric acid and heat. That is a secondary alcohol. So when we protonate the secondary alcohol, it's prone to undergoing elimination and carbocation formation. Because of the proximity of two methyl groups next door, that quaternary carbon, we can improve the stability of the carbocation that results by doing a methyl shift. And so we would see here this positive charge, and then we'd see immediately that methyl shift occurring. And so what that does is it gives us our 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7 membered or parent chain there, and then the final resulting elimination product after the shift would give us this Zaitsev type product, tetrasubstituted, and an E stereoisomer to put the biggest groups on the opposite sides of the alkene. Okay? With our POCl3 and pyridine, however, we don't have a carbocation formation, and so we're going to undergo an E2 elimination that is unable to eliminate to this side because there's no beta hydrogen. We have to eliminate from the anti-periplanar beta hydrogen on the other side, and so we can do that leaving these two methyl groups in place and forming again the E stereocenter in order to maintain the the most stable alkene possible. Since we do have two beta hydrogens to choose from, it can rotate into this configuration and eliminate directly to the more stable alkene. But we don't see the methyl shift. Again, counting our carbons to make sure everything is present. Stereochem errors were a point deduction. All right, so now we have a primary alcohol that we are going to convert in an intermediate step here, the first step, to a primary bromide through the basic alcohol substitution reaction. That's a good leaving group on a primary carbon, and so when we go to do the acetylide synthesis, it is a good nucleophile as a carbanion and is a strong base. Okay, so that's again from our acetylide synthesis, but here we're adding it after converting an alcohol to a halide, but it's the same. As we're putting together the rest of the parent chain, this is actually not a chiral center here because there's two ethyl groups attached to this carbon. So we don't need perspective there. We could redraw it with perspective if we wanted to. This chiral center does remain unaffected and must be labeled with the correct configuration. From there, we get all our carbons, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, and then we add our 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons from the acetylide. Make sure we're counting everything up. Simple carbon addition errors would have been a 1-point penalty, as well as stereochemical errors. This bond is linear because, again, it's an alkyne. sp hybridizations 180-degree bond angles. Okay, next up we've got tosylate formation. So the first thing we do is convert to a tosylate in pyridine here on the secondary alcohol. We retain the configuration. Okay, well then we have a good nucleophile. Here methoxide is a good nucleophile and a strong base. And so with a secondary tosylate, remember we said tosylates are good leaving groups. They react like alkyl halides. This is actually going to be an E2 major product and not an SN2 major product here. Because we've got beta hydrogens to either side and they're both equally substituted, we end up with two possible major products that should form in roughly equal quantities. If you only drew one of them on the exam, however, we did give credit 2 points for either one of these in the E configuration. If you did draw the SN2 minor product, you got 1 point. So these were both +2. And then we said if we had a minor inverted methoxide here, SN2 would have been +1 for drawing the minor product. You were correct. It is formed. It's just not formed as a major product here. Looking at our next example, we've got a very similar outcome here. We convert the alcohol into a chloride with inversion. And then we've got this good nucleophile and strong base again. And so again, for a secondary leaving group, secondary halide, E2 is again the major product. It's the same two products we saw before. Should form in roughly equal quantities because they are very similar in energy due to them both being di-substituted. Again, but you got 2 points for having either or. And so we really only had 2 points associated with either one of these. And then if you drew the SN2 product, you got +1 for drawing the minor product. But if you drew it correctly, we would have had inversion back here to the wedge versus the dash. Okay, because PCl3 inverts to begin with, tosylate does not. So we get two different enantiomers there for the minor product if you ended up drawing the minor product instead.